Yeah. Today I'm going to start the Bessel function. Before I'm starting the Bessel function, I would like to first say or suggest you to make your own notes because when you're going to prepare for the finals, you're going to have your handwritten notes because handwritten notes is very important for every student. So Bessel function, which is triple students and as well as the EC students are going to learn this subject. First, we are going to see the Bessel functions definition is what that we are going to see. So the differential equation of the form x square y double dash plus x y dash plus of x square minus n square of y is equals to 0. We'll mark that is equals to equation 1. Or the same equation 1 can be represented as y double dash plus 1 by x y dash plus of 1 minus n square by x square of y is equals to 0 is called Bessel equations of order n, where n is non-negative constant. We solve equation 1 in series by using Frobenius method. So this is your Bessel function. Now we will see the definition of Bessel function is what? Definition. Bessel function of first kind of Bessel function of first kind of order n is denoted and defined as Jn of x, which is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 of x by 2 whole to the power of 2r plus n, where n is any non-negative constant, any non-negative constants. Bessel equation of, oh sorry, it is Bessel function of second kind of order n is denoted and defined by j. Just we are going to substitute n is equals to minus n in the first kind of order n. So j minus n of x is equals to summation r is equals to 0 to infinity minus 1 to the power of r 1 divided by r factorial gamma of minus n plus r plus 1 of x by 2 to the power of 2r minus n, which is also known as Bessel function of the first kind of order minus n. Hence, Jn of x and j minus n of x are two independent solution of equation 1, where we have denoted the equation 1 to the Bessel equation. Hence, the general solution of Bessel equation 1 is y is equals to a of j minus n of x plus b j n of x, where a and b are arbitrary constants, where a and b are arbitrary constants. Next, we will see the expansion for J naught of x and J1 of x, which is important for 1 mark. Those students that are going to be under JNQ. Expansion for J naught of x and J1 of x. So we are going to define with the help of Bessel function for first kind of order n. So by the definition of Bessel function, Bessel function is, or we are using here first kind of first order. Jn of x is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 of x by 2 to the power of 2r plus n. Will mark this is equals to equation number 1. Now what we will do, we have to find j naught of x. So we will substitute n is equals to 0 in the equation 1. Substituting n is equals to 0 in equation 1, we get j naught of uh, j naught of x what we are going to do, we have to substitute n is equals to 0 in the equation number 1. So j naught of x is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r we are substituting for 0. So 0 factorial it should be. Gamma of x by 2 to the power of 2r plus n, or here r factorial I have written, that should be it is equals to 0. J naught of x, which is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of r plus 1 x by 2 to the power of 2r. Now we have to open this series summation. When we are going to substitute r is equals to 0, 1, 2, 3, 4, 5, 6, so on till infinity. But till infinity we cannot substitute. So we will substitute 3 to 4 values. First we will substitute when r is equals to 0. What we are going to get? J naught of x is equals to minus 1 to the power of 0 by 0 factorial gamma of 0 plus 1, 0 plus 1 of x by 2 to the power of 2 into 0, where 0 factorial is equals to 1, gamma 1 is equals to 1, something to the power of 0 is also equals to 1. So what we are going to get here, simply 1 we are going to get, 1 by 1 of x by 2 to the power of 0. So again here something to the power of 0, it is equals to 1. So when r is equals to 0, we'll get j naught of x value is equals to 1. Now we'll move for substituting r is equals to 1, the second value. When r is equals to 1, j naught of x, which is equals to minus, yeah, here we have to substitute. Summation to infinity we have to open. So now what we are doing, we are substituting r value is equals to 1. So we are going to get minus 1 to the power of minus 1 into 1 by 1 factorial gamma of 1 plus 1 x by 2 to the power of 2 into 1, where we having the knowledge n plus 1, gamma n plus 1 is equals to n into gamma n. So gamma 1 plus 1, we can represent 1 into 1, where in the place of n, the value is equals to 1. So gamma 1 value is equals to 1. So j naught of x value we are going to get minus x by 2 to the power of 2. Now next we will substitute when r is equals to 2. What we are going to get when r is equals to 2. J naught of x, that is equals to minus 1 to the power of 2, 1 divided by 2 factorial gamma of 2 plus 1 x by 2 to the power of 2 into 2, where you see that gamma that is already in the form of gamma n plus 1. In place of n, the value is equals to 2. So minus 1 to the power of whole square is equals to 1. So 2 factorial 2 into gamma 2 of x by 2 whole to the power of 4. Where again the gamma 2 we can write 1 plus 1, 2 factorial is equals to 2, 2 into 2 gamma 1 plus 1. Again it is in the form of gamma n plus 1, x by 2 to the power of 4. That is equals to n gamma n plus 1 is equals to n into gamma n. N into gamma n. So what we are going to get, 1 by 2 into 2 into 1, gamma 1 of 1 is equals to 1, x by 2 to the power of 4, which is equals to 1 by 4 into x by 2 to the power of 4. So in this way we have to continue. So three values is enough. Where we got j naught of x is equals to 2. When r is equals to 2, we are getting the value that is equals to 1 by 4 of x by 2 to the power of 4 and so on. When we are going to continue, we are going to get some values. Now what we'll do, we'll represent like a series. We are going to add all the values. So first value it is was 1 minus of x by 2 whole square plus 1 by 4 of x by 2 to the power of 4 plus so on. So this is also known as the zeroth order of a Bessel function. This is known as Bessel's function for zeroth order. Zeroth order. Now we have to move for finding the j1 of x in the similar way. First, what we are going to do, we are going to substitute n is equals to 1 in the equation 1, where the equation 1 is your Bessel function of a first kind of order n. So we will substitute n is equals to 1 in your equation number 1. In equation 1, substitute n is equals to 1. J1 of x is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of r plus, oh sorry, we are substituting n is equals to 1 now. So 1 plus r plus 1 of x by 2 to the power of 2r plus 1 plus 1, where 1 plus 1 is equals to 2. Summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma r plus 2 of x by 2 to the power of 2r plus 1. And similar way, we will open it by substituting r is equals to 0, 1, 2, 3, so on. So first we'll substitute r is equals to 0 in this equation. We'll mark this is equation number is equals to 2 when r is equals to 0. J1 of x is equals to summation minus 1 to the power of 0, 1 divided by, where we are substituting in the above equation 0 factorial gamma of 0 plus 2 of x by 2 to the power of 2r plus 1, where we are substituting r is equals to 0 na? So this has to be 0. I have written it 0 r, so it should be 0, 2 of 0. Something to the power of 0 is equals to 1, 0 factorial is equals to 1, where gamma 2 can be represented as gamma n plus 1, that is 1 plus 1. We can write gamma 2 of x by 2 to the power of 1, gamma 1 plus 1 x by 2, where we know that gamma n plus 1 is equals to 1 into gamma 1 x by 2. So when r is equals to 0, we got the first value j1 of x is equals to x by 2. Now we'll move for when r is equals to 1. When r is equals to 1, j, here we are substituting, that will mark is equals to equation number 20, not marked over there. So let me mark it. Yes, 1 is assigned. So we'll take that equation number is equals to 2. So j1 of x is equals to minus 1 to the power of 1, 1 divided by 1 factorial gamma 1 plus 2 of x by 2 to the power of 3, 2 plus 1, minus 1 into 1 factorial is equals to 1, where gamma 1 plus 2 is equals to gamma 3 x by 2 to the power of 3, where gamma 3 we can represent in the form of gamma n plus 1, which is equals to n into gamma n, minus 1 into 1 divided by gamma of 2 plus 1 into x by 2 to the power of 3. So that will be equals to minus 1, 1 by 2 into gamma 2 x by 2 to the power of 3. Now again that gamma 2 we can write gamma 1 plus 1, gamma 1 plus 1 x by 2 to the power of 3, minus 1 divided by 2 into 1 x by 2 to the power of 3. j1 of x is equals to minus 1 by 2 x by 2 to the power of 3. Now we will similar way when we are going to substitute r is equals to 2, I will give you the direct answer. You calculate and check whether you are getting again the same answer or not. When r is equals to 2, j1 of x is equals to minus 1 to the power of 2, 1 divided by 2 factorial gamma 2 plus 2. Directly I am giving the answer. So x by 2 to the power of 5, that is equals to 1 by 12, 2 factorial is equals to 2, 2 into 6 is equals to 12, x by 2 to the power of 5. So on. Three values it's enough. Now we are going to add all the values what we got for j1 of x when r is equals to 0, 1, 2, 3, so on the values. So first value it was x by 2 whole square minus 1 by 2 of x by 2 whole cube plus of 1 by 12 of x by 2 to the power of 5 minus so on. Now from this throughout one, we can take x by 2 value as common. X by 2 whole square of 1 minus 1 by 2 of x by 2, then plus 1 by 12 of x by 2 to the power of 3 x x by 2 to the power of 3, so on. The graph can be represented in the form of a cos x and sin x. The graphs of j naught of x and j1 of x closely resemble the graphs of cos x and sin x respectively. Roughly, I will show you the graph how it is going to be represented. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Z axis. So it is equals to y axis. One, 2, 3, 4, so on. This is for a j1 of x, and this is for a j naught of x. When you're going to check it on a breadboard, you're going to see the graphs on ECGs. How it is going to be overlap like a cos x and a sin x. So this is again the complete basic theory of what is the Bessel functions, where I have said you what is the Bessel equations definition, and again J naught of x expansion and J1 of expansion with the graph. Make a note of this one, so that for your finals it will be easy for you. If you like my way of explanation, give a thumbs up and share it with your friends. So it's going to be a kind of a help for your friends those who are having a supply and they are not able to follow the class properly, so they can watch these videos. Where once again I'm saying concept is very important. Make the concept clearly. Thank you.